Okay, so tonight we're going to wrap up Chapter 6 talking about formulas. So not every problem is going to have exactly the same formula. So we're just going to look at a couple of formulas here for our examples. But the number one thing that has to go along with formulas is your job is to make sure you get the numbers in the right places. If you get the numbers in the wrong places, that's going to lead to confusion. So it's going to be very important to get numbers in the right places. So if we look at our first example here, we have an airplane that has a 1,600-mile round trip. It's a 10.5-hour flight. So the question is, how fast is this airplane? So again, right off the bat, we can see here we got a 1,600-mile trip. So this is our clue that we're going to be using our distance formula. Okay, and we went over this in class again. So what's going to be important for us now that we know what formula we're going to use is getting our values in the right places based on context clues and some different things we've talked about during class time. 1,600 miles is the distance of our trip. So based on that, we want to substitute 1,600 in for our D for distance. It's a 10.5-hour flight. Rate or time, that is a time. So once we fill in what we've been given in the problem, we now see that our rate, or R, is the piece that it's our job to calculate. Again, notice I have went ahead and rewrote 10.5 as 10.5 as a conversion. Based on our algebra skills that we've been talking about, to solve this for R, we would need to divide both sides by 10.5. So R equals, and to save time here, I'm cheating, 1,600 divided by 10.5 is 152.4. Now I'm going to change that to squiggle equals because I rounded that. Alright, so this plane is flying approximately 152.4 miles an hour. Okay, so again, the important thing that for these formulas is not that they're complicated, it's getting the numbers in the right places. All right, and then once we get numbers in the right places, then we realize what steps we have to do to come up with our missing term. Okay, second option we may be given down here, we have a little right triangle. Okay, that's 11 inches by 16 inches by 19 inches. So the question is, what's the area of the triangle? So again, we're going to need to recall a formula for area of a triangle. Okay, our formula for the area of a triangle is 1/2 base height. That's our formula for the area. So based on that, we need to determine which side is our base. 16 inches is our base, so we can substitute in the 16. And our height is 11. Remember, base and height usually are perpendicular here. So the area is 1/2 times 16, that would be 8. So 8 times 11 is 88 square inches for the area. Okay. So again, notice with two examples here, this example down here, once we have all of our values placed in the formula, all of our values were side by side, we can just go ahead and work that problem out as is. Up here in the distance formula, the two terms were on opposite sides of the equal sign. So this is where our algebra kicks in. This is where we need to recognize, okay, our terms are separated. That's when we need to do the inverse. That's why we chose to divide our two numbers here instead of multiply. All right, as always, bring any questions you have to class tomorrow. Have a good night.